everyone. Here's a quick helper video to help you with the assignments in this week's folder entitled Density and Density 2. Okay, so first of all, let's talk about density just for a moment. Right? What is density? Well, density is the amount of matter per volume. Right? So things that have a lot of mass packed in, nice and tight, like all the little atoms or molecules. Let's say we're talking about a chunk of maybe iron or something. So all these iron atoms are close together, they're lined up pretty well. Each atom is also quite heavy, right? Each little atom is quite heavy because within the atom's nucleus is the vast majority of the mass. And iron has a lot of protons and a lot of neutrons, right? And so that adds mass. If there's a lot of stuff inside of the nucleus of the atom, that adds mass, right? And so each one of these, they're tightly packed together. That adds to their density. That affects the density. And also what they're made out of affects the density. If there's lots of stuff in the nucleus, and you've got similar spacing, it's going to be more dense. And if you've got fewer things in the nucleus, it's going to be less dense and or greater spacing. So for example, I don't know, let's compare a piece of iron, a little chunk of iron, right? We all have an intuition that iron is relatively heavy, right? What if we have a chunk of styrofoam? Well, styrofoam has a lot of air, right? In fact, think about the name of the stuff, foam. Right? So styro, foam, F-O-A-M. What's foam? Well, it's stuff that's, I don't know, foamed milk or water with a lot of foam in it. There's a lot of air involved, right? So this does not have a lot of density. Say this is styrofoam or something, styrofoam, right? This has the atoms are really spread out. The molecules are really spread out. There's a lot of air in there. So this does not have a lot of density. If you had two chunks of this stuff, a chunk of each, right, and they're the same size, we have this piece of iron, it's a little cube or something like that, and we have the same size piece of styrofoam. Well, everybody here is going to guess, which one weighs more? Well, if they're the same size, the iron weighs more. Well, okay. Why? Well, because it's got more density, more stuff packed into the space, and this has less stuff packed into that same space. Right? So how do we quantify density? Well, density is simply the amount of stuff divided by the volume. So density is mass divided by volume. Remember when I was a kid, they used to say stuff like, density is love. Right? Density is love. You put a line through it, m divided by v, mass divided by volume. Just a little mnemonic device to help you remember in case you don't remember density. But let's work this out. Okay? So here's a little sample cube, and let's say it's a cube. So if I say it's a cube, that means all the sides are the same. It's 4 by 4 by 4 centimeters. So we can go ahead and fill that in if we want to. 4 centimeters, 4 centimeters. Well, there's its mass right there. So I'm going to run density is mass divided by volume is 160 grams divided by the volume. Well, what's the volume? Well, for regularly shaped objects, the volume for cubes and rectangular solids and cuboids, all these things that are easy to calculate, the volume is length times width times height. Okay, there's volume of a regularly shaped object. Right? So, length, width, and height are all the same on this object. So the volume of this thing is 4 times 4 times 4. Okay, so what's that? 64, I believe, right? 4 cubed is 64. Let's break out the calculator. Just double check. So you can do it this way: 4 length times width times height equals 64. Yeah. So that's a lot of button pressing and keystrokes, etc. You could also just do this. If you turn your phone sideways, you'll see a scientific calculator. Or if you use the one that's on your computer like I'm using, you can just 4 cubed. That means 4 times 4 times 4, 64. So I can do it with 2 keystrokes, right? I can do it with 2 keystrokes. That's helpful. Clear. 4, what's 4 cubed? 4 times 4 times 4 is 64. Okay. Well, so the density is going to be 160 divided by 64. Those are cubic centimeters. Okay, so my density is going to be 160 divided by 64. So I break out the calculator again, and I say 160 divided by 64 is 2.5. 2.5 what? Grams per cubic centimeter. Grams per cubic centimeter. What does that mean? Well, if I had a little cubic centimeter of this stuff, well, 1 by 1 by 1 centimeter. It's like a half inch by half inch by half inch, a little bit less, right? A little cube, 1 by 1 by 1 centimeter. That would have a mass of 2.5 grams, right? That'd be 2.5 grams if it's 1 centimeter by 1 centimeter by 1 centimeter. Sorry, that's hard to read. That's a 1 by 1 by 1 centimeter cube, and it would have a mass of 2.5 grams. That's what this means. 2.5 grams per every little cubic centimeter. Okay? Now, I do ask you on occasion, in fact, I think on this assignment, on nearly every problem, to also state this in kilograms per cubic meter. Right? Well, a cubic meter is a big thing. Right? A cubic meter is a meter, which is about 3 feet, just over 3 feet. Right? A meter is just bigger than a yard. So 3 feet by 3, so this is a much bigger cube than that, right? This is a half inch by half inch by half inch, not even. This one is 3 feet by 3 feet by 3 feet. This is the size of a giant washing machine at the laundromat or something like that, right? That's 1 meter by 1 meter by 1 meter. Okay, now you probably remember that in 1 meter there are 100 centimeters, right? So we only have to do this once. Let me just show you. So how many cubic centimeters are in a cubic meter? Well, I don't know. This is 1 cubic meter here. And it's 100 centimeters by 100 centimeters by 100 centimeters. So its length in centimeters times its width in centimeters times its height in centimeters is 100 times 100 times 100 is 1 million, right? So 1 cubic meter is actually 1 million of those little guys. Right? You can fit 100 across, and then you can have 100 rows just to cover that face, and you can do that 100 times, right? So 1 million cubic centimeters is a meter, okay? And also the other thing is a kilogram is 1,000 grams. That's what kilo means, 1,000, 1,000 grams, okay? So how many grams, how many cubic, sorry, let me start again. How many kilograms per cubic meter are equivalent to a gram per cubic centimeter, or better yet, how many grams per cubic centimeter are in a kilogram per cubic meter? Or simplest yet, how do I turn this into kilograms per cubic meter? Well, what I do is this. I do conversions, and you only have to do this once, and I'll show you the shortcut, but let me do it properly first. So 2.5, I'm just taking this as an example, 2.5 grams per 1 cubic centimeter. I want to convert that to kilograms per cubic meter. Well, I've multiplied by things that will help me convert, like there are 1,000 grams in a kilogram. That'll cancel out the grams. Now I'm at kilograms per cubic centimeter, but I want to be at kilograms per cubic meter, so there are 1 million. There are 1 million cubic centimeters in 1 cubic meter. Now my cubic centimeters will cancel out, and my units are going to be kilograms per cubic meter. So look what I have to do mathematically. It looks scary, but it's not. Watch. 2.5 times 1 million. Okay, well that's 2.5 million. Divided by 1,000. Okay, well that's 2,500. Right? So in each and every case, when you want to go from grams per cubic centimeter to kilograms per cubic meter, you multiply by 1 million and you divide by 1,000. Which is, some of you are probably already thinking this. Let's just do this. Scratch off 3 zeros. Scratch off 3 zeros. That becomes a 1, right? So multiplying by 1 million and dividing by 1,000 is the same thing as simply multiplying by 1,000. So all you have to do to turn this into kilograms per cubic meter is multiply by 1,000. Move the decimal 3 places. Right? So the density of the cube here, that's a D, sorry. The density of the cube is 2.5 grams per cubic centimeter. We'll just move the decimal 3 times. That's 2,500 kilograms per cubic meter. So you just multiply by 1,000. Whatever you get here, just multiply by 1,000, and you'll have it in kilograms per cubic meter. The last thing I did want to say was this. I have this box here drawn for a reason. And the other day in class, I don't have the gear with me, otherwise I'd do it again right now, but I just don't have the scales and the little syringe and everything that I had with me at school. But I 3D printed a little box. It took me about 3 minutes to draw the thing, and with the inside dimensions of 10 by 2 by 1. Right? And so I took a little syringe. I had a syringe in the back room there, the reason I used a syringe is because it deals with very small amounts of liquids accurately, right? So gosh, that's bad, but whatever. Right, so I filled up this syringe. There's the little handle thingy. Right, I filled up the syringe with 10 milliliters of water, right to the line, right? And I came over here and I squirted 10 mils in, and it was half full. And then I did it again, and I added 20 milliliters. So I added 20 milliliters of water to this little box, and it filled it perfectly. Well, look at the volume of this box. Length times width times height. 10 times 2 times 1. 10 times 2 is 20. Times 1 is 20. So this box here has a volume of 20 cubic centimeters. And it's also got a volume of 20 milliliters. So milliliters and cubic centimeters are the same thing. Right? This page is getting kind of full. I'm going to flip over here. Milliliters and cubic centimeters are the same thing. Right? So 1 milliliter is 1 cubic centimeter. And the reason that's important is because what we do sometimes when things are hard to calculate the volume for, right? So say you have this rock. It's a rock. And I'm not even going to try to draw it in 3D. There's a rock, right? And how do you measure that thing's volume? You can't do length times width times height. It would just be full of trouble and really, really difficult to do well, right? So what do? Well, we can take this rock and put it into a graduated cylinder. So here's a graduated cylinder with some water in it. And let's say I had the water at the 100 milliliter line, right? And then I drop the rock in. Right, so sorry about the bad drawings here. I drop the rock into the water. So there's the rock, now it's in the water. And the water goes up a little bit, maybe to the 120 milliliter line. Right, so the water goes up. Well, why? Well, because the rock pushed water out of the way. The rock displaced water. Okay, well, how much water did it displace? Well, 20 milliliters, right? It was at 100, now it's at 120. The water went 20 higher. So why? Because the rock has a volume of 20 milliliters. And if the rock pushes the water 20 milliliters higher, then we know, since a milliliter is a cubic centimeter, that the volume of the rock is 20 cubic centimeters. So let's say, I don't know, let's just say that we had the rock on a scale too, and let's say the mass of the rock is something that's easy to deal with, 120 grams. Let's say we knew the rock had a mass of 120 grams. Well, what's the density of the rock? Well, it's the mass divided by the volume, and the mass we just read right off of a scale, 120 grams, and I divide it by the volume. In this case, the volume I got from water displacement. Right? And so the water volume went up by 20, so the rock's volume is 20 milliliters or 20 cubic centimeters, and 120 over 20 is 6. So the density of this rock, I would say, is 6 grams per cubic centimeter. Oh, what's that in kilograms per cubic meter? Just multiply by 1,000. Density of that rock is 6,000 kilograms per cubic meter. Okay. Oh yes, before you go though, one more thing I did here too was when I filled this up with water, I had it on a scale. And the scale, I zeroed out with a plastic thing on it. So the scale read 0 with a plastic container on it. And I filled it up with water. Guess what the water was? Guess how much the water weighed? The mass of the water that fit in there was 20 grams of H2O. Right? So 20 grams of water fits into a 20 cubic centimeter box. So just a quick, what's the density of water? Well, let's see. 20 grams of water fit into a 20 cubic centimeter box, and 20 over 20 is 1. Water has a density of 1 gram for every cubic centimeter, which is equal to, multiplied by 1,000, 1,000 kilograms per cubic meter. Right, so there's the density of water for you. 1 gram per cubic centimeter, or 1,000 kgs per cubic meter. And that's it. That should help you out with these 2 assignments in this week's folder. Good luck, and as always, email me with any questions. Bye-bye.